I feel like that you should know that we're going to talk about graphing linear equations. Your objectives, as they're written here on the board, are being able to identify linear equations and graphing a linear equation by finding and plotting ordered pair solutions. We called that a table of values. Okay. Now, let's talk though about identifying linear equations. What does it mean for something to be linear? If it's linear, what is it? Yes,
like
sir.
Line?
It's a line. Okay. What type of line? A straight line. Now, there are three types of linear equations. Okay? So this part I want you to just watch on. Everybody watching? All right. There are three types of linear equations. If I asked you to draw a straight line, okay, what might be one type of straight line you would draw? If I said, you know what? Draw a straight line. Okay? So if I said, you know, on your white woodworking, I want you to draw a straight line. What type of line might you draw? Yes, ma'am. A horizontal line. What does a horizontal line look like? Okay, it looks like this. Okay. So here's what my horizontal line looks like. We call it horizontal. Right? All right. Now, what might be another type of line? A diagonal line. O-N-A-L. Always have to stop and think about it. O-N-A-L. Now, what does a diagonal line look like? Oh, I see some. I can't quite figure out if we're dabbing or I'm not sure what we're doing. I mean, yeah. Oh, see? Oh, we could dab, and if we dabbed, what kind of horizontal lines would we have? I mean, what kind of lines would we have?
Diagonal.
We would have diagonal and horizontal. It's like the best of both worlds. And then if you put your body in the mix, you got a what? Vertical. I mean, it's amazing. Oh my gosh, it's amazing. Okay, so then we also have vertical. Now, all right, so horizontal, vertical looks like so. Everybody agree? And then diagonal, though, can look like what? Because now you're all going to dab. I can see it coming. I know, every one of you are going to do it. Okay, but what if I dabbed like this way?
It's a negative.
It's a negative. So I can have two different types of diagonal lines, right? So I can have the one that comes up like this, right? What type of vertical line is that? Yes, sir. It's a positive. Because remember, we read it as it comes from left to right. So it's positive, but then I can also have the kind that looks like this, and it is what? Negative. Now, that being said, we can identify them based upon what they look like. Like, we can look at that and we're like, oh, that's linear. Everybody agree with that? Like, we can all visually see that the lines are linear. But our objective is to identify linear and nonlinear, not based on what we see in terms of the graph, but based upon the equation. So not only is it important for us to be able to identify them horizontal, vertical, diagonally, we also have to be able to identify them based on their equation. So what type of equation would a horizontal line have? Anybody know? Think you might know? You might not know, and that's okay. Yes.
Is it a 0?
It is. That's what you're thinking slope.
Yeah.
Okay. You're thinking slope. But the slope of that is 0. Yes. The slope of that line is 0. But not what the equation is. What is this? So if I said, what's the slope? You would say 0. Okay? But if I said, what's the equation? that's gonna look a little bit different. Okay? Anybody know, you think what do you got?
X equals Y.
Not x equals y, although that is a legitimate equation, just not for horizontal. It's diagonal. Okay? Anybody else got a thought?
Could it be like at least like one? Like, not just X equals Y, but like X equals something.
It could be. Again, those are going to be diagonal. I want the equation for just horizontal. Y equals x is the same as x equals y, it's still diagonal. How about this? Which way does my horizontal lines run? Straight across, left to right? Everybody agree? If I graphed it on a number line, if I graphed it on a coordinate plane, what axis would it go through?
X.
Would it?
What Y? Y.
It would go through y, it would pass through y. Everybody agree? So when you see a horizontal equation, it's going to be y equals a number. Okay? It's going to be y equals some number. Doesn't matter what that number is. And we would graph it by, if it's y equals, what, 2? And this were my order, and this were my coordinate plane. I would go to where y was 2. Let's change colors so we can see what color you want. Anybody care? Red's always a good color. Then y equals 2 would be this line right here. Because there's my origin, there's 1, there's 2, there's where y is 2. That's my horizontal line for y equals 2. Does that make sense? Yes, sir.
When you do that, you have to make your line all the way across the,
Well, what do these arrows here indicate?
that they never end.
That it never ends. Okay, so we only see a snippet of the line, not the whole thing. Okay? Now, if you have an ordered pair that's horizontal, do you care what your x is? You're only looking to see, because if it said, give me an ordered pair that makes this equation true. Do you care what your x value of that ordered pair is? No, the only thing you care about is your y value. You want your y value to be 2. So it could be negative 1, 2, 5, 2, 7, 2, negative 10, 2, as long as your y value is 2. Does that make sense? Yes, sir.
Okay, so if you did like -5, would you have to graph -5?
You would have to come down to negative 5, and then you would have to draw your line. If it's y equals negative 5. I'm assuming that would be what you're thinking. Okay? Now, that being said, let's switch back. What about our vertical lines? What might the equation for a vertical line look like? Yes, sir.
X equals a number.
X equals a number. You all catch on quick. All right, x equals a number. Everybody okay with that? Because if I were to graph this line on a coordinate plane, what axis would it run through?
X.
It would run through our x axis. Everybody agree with that? And it's going to be x equals a number. You graph it just like you would for y, only when it's x, it's going to run straight up and down. We established the slope for the horizontal is what?
Y equals a number.
No, slope for horizontal.
0.
0. Slope for vertical? Bo Stratton.
Is it like undefined?
It is exactly undefined because it doesn't pass what we call the vertical line test, which we're going to talk about later. Okay? So vertical lines can't pass the vertical line test, and so therefore they have an undefined slope. Okay? So we've got y equals a number, we've got x equals a number. This is the one that you're the absolute most familiar with. You will know it if you don't already, forwards, backwards, and inside out, and you will know how to put an equation in its form. Yes, Mackenzie?
Y equals mx plus b.
Y equals mx plus b. So a while ago, when you told me y equals x, that's in a 2-variable form. Now, this is an equation, we call this, what form is this? Anybody remember? What do we call it? Yes, sir?
Slope-intercept.
Slope-intercept. Okay, so this is slope-intercept form. Where do I find my slope in slope-intercept form? Where do I find my slope from slope-intercept form? Yes, Bo Stratton? Is it the M or is it the X or is it both? It's just the M. The M is my slope. What's the X? It's the variable, but not for the X-axis. It's not the Y. B is the Y-axis. Okay, or the Y-intercept, right? Okay. So M is our slope, we've established. B is the Y-intercept. So what's the actual X and Y? Yes, sir.
Would be like the negative, like it's negative or positive.
Well, isn't that our slope? Okay. Yes, ma'am.
Would it be the coordinates?
The coordinates of what? I agree that it's the coordinates, but it's the coordinates that does what?
The rate.
The what?
The rate.
The rate. The rate of what? Our rate of change?
Yes.
But our rate of change is the same as our slope, right? Oh, yeah. So if we go back to what Mackenzie said and we say it's our coordinates, what have we learned about coordinates?
X is your first coordinate and then Y is your second coordinate.
True. Where can I find these coordinates? On the graph. Where on the graph? What are we graphing?
Diagonal line.
The diagonal line. So where would these coordinates be found?
On the diagonal.
On the diagonal line. And if the coordinates are on the diagonal line, what can we say about those coordinates? They are a... Starts with an S?
Solution.
Solution! They are a solution. Okay? And what does it mean when something's a solution to the equation?
It makes the equation true.
It makes the equation true. Which means that the ordered pair that we substitute in for X and Y would be an ordered pair that we found on the line that would then in turn make both sides of the equation true. Okay? Does that make sense? Alright, now, horizontal is Y equals a number, our vertical is X equals a number, and diagonal is Y equals MX plus B. Everybody okay with that? We're going to look today, based on just looking at our equations, if it's linear or nonlinear. Because sometimes we have equations that are linear, which will give us one of these three lines. Sometimes we have some that are not linear. Maybe they're quadratic, maybe they're absolute value. Okay, they'll give us different shapes. So, let's start by our definition. I gotta switch. Let's start using our definition of, maybe I'll switch. There we go. Okay, so let's look. The equation x minus 2y is equal to 6 is called a linear equation in two variables. How is that different from the horizontal and the vertical equation? Luke?
It has like two variables.
Okay, but what did horizontal and vertical have? Let's go back and look. Here's my equation for horizontal. Here's my equation for vertical.
Has an X and a Y in it?
This one does have an X and a Y in it. These have a what? Only what?
Only either an X or a Y.
Either only an X or a Y. These are in terms of one variable. It's going to be the variable and the number. Everybody agree? These are in terms of both X and Y. That's why we call it a two variable. Man, how do I get back to where I was? There we go. Okay. So, it has to have two variables and the graph is very linear. Alright? A linear equation in two variables is an equation that can be written in this form. Remember, we're watching. You don't have to write this. I'm going to put everything up on your Google Classroom. Okay? So, AX plus BY equals C. That's called standard form. It's what we usually see it in when we first look at it, right? How many of you are remember, like 2x plus 3y equals 6. That's how it starts out in, and then they ask us to do something with it. You familiar with that? Okay, good. So A, B, and C are real numbers, okay? And both of them can't be 0, because if both of them are 0, then we're back to a one variable equation, okay? Standard form, all right? But what do we know about our exponents here? You guys are talking about exponents and pace, right? And that's important because linear equations are determined based on their exponent. So what is my exponent right here for x? 1. Ainsley, what is my exponent right here for y? 1. Okay? Linear equations have their variable exponents of 1. If it's anything else, it's not linear. Okay? So our variable exponents have to be in terms of 1, or it's not linear. So let's look. 2 variables. This is standard form. If I'm looking, what's my exponent for x? No. What's the 2? It's the coefficient. What's my exponent? 1. It's just understood to be there. Everybody agree? Austin, what's your question?
What if they were like both like the same number? Like besides 1, like what if they were both 2?
So what if it looked like 2x squared plus y squared equals 8?
Yeah, like if they're the same number, does it
But it has to be in terms of an exponent of 1. Does that have an exponent of 1? Not linear.
I didn't know if it made a difference if it was like this.
Good question. It doesn't. Okay? Everybody okay with that? Those are good questions. Okay. So, exponent of 1 here, exponent of 1 here. Is it going to be linear when we graph it?
Yes.
Absolutely. Exponent of 1 here, exponent of 1 here. Is it going to be linear? Yep. Exponent of 1 here, exponent of 1 here. It's going to be linear? What about here? Is it going to be linear? Yes. But is it a 2-variable linear? No. So would it be diagonal? No. What would it be? Horizontal. Good job. Okay? Everybody okay with that? Now, on your white when working. Okay, so on your white when working, I want you to do 2 things. The first thing I want you to do is I want you to write me an equation that is linear. Then I want you to write me an equation that's not linear. Okay? So write me an equation that's linear, write me an equation that's not linear, and then let me know when you're ready. On your white when working, write me an example of an equation that's linear, write me an example of an equation that is not linear. And be prepared to share and tell me why or why not that it's linear. Either why it is or why it isn't. And then let me know when you're ready. Share. You can be prepared to share if you want to. Okay. We're almost already here. We're almost ready here. We're almost ready here. Ready, ready. We're ready over here. Okay, we're ready over there. Oh wait, Swivl's almost ready. Okay. Where'd my pen go? Here it is. All right. Who would like to share their red when or their white when working? So flip to your white when working. Hold it up. Let me see actually real quick. love it, love it. Love it. Good job labeling. Okay, I see a lot of great answers. Who wants to share yours? Lala, tell me what you got.
Okay, for linear, I got 8x.
Okay, hold on, wait, let me make a chart. Linear, non-linear. All right, go.
8x plus 20y equals 80.
All right, and what'd you get? Do you want to share your non-linear too?
Yeah.
Go ahead.
8x to the third power
Ooh.
plus 10y to the third power
Okay.
equals 19.
All right. All right, hey, let me ask, do we all agree with her? Anybody disagree with her? Okay, who can tell me why hers is linear? Yes, sir.
The exponent is 1.
Because the exponent of what is 1?
The variable.
The variables. And primarily we focus on the variable of x. Okay? If y is a different exponent, it's not going to be linear. But y can be a 1 and x can be something else, and it's still nonlinear. Okay? They don't have to both have the same exponent. All right. Why is this one non-linear? Yes, ma'am. The exponent's 3. Now, if I were to take this out, would it still be nonlinear?
Yes.
Yes. Okay? Who else has one that they want to share? Let's see. Who have I not talked to today? I have not talked to you today. Wait, I want to say Isaac, but I know that that is wrong. Tyler.
Yes,
Go.
I put 3x plus 2y equals 10.
Hold on. You put 3x plus 2y equals 10. I love it. What else you got?
3x squared plus 2y squared equals 10.
All right. Everybody agree or disagree? Do we agree or disagree? We agree? Okay. I saw some. Luke, share with me, or us, I guess. Share with us your linear.
Y equals 4.
Y equals 4. Is that linear?
Yes.
Yes. Is it a two-term variable? What kind of line is that going to give me? Horizontal. Still linear though, right? But if it says two-term or two-variable, it wouldn't be. So just be careful how the question's worded. Okay? What was your nonlinear?
2x to the 4th plus 6y squared equals 19.
All right. Everybody okay with that? Perfect. All right, erase your white one working. And on the side of your white one working, I want you to label A through D, and then I want you to say yes or no. Be ready to tell why. So write yes or no for each one. Be ready to tell why. Ouch. Let me know when you're ready. All right, let me see what you got. Linear, non-linear. Yes, yes, no, no. Yes, yes, no, no. Yes, yes, no, no. Yes, yes, no, yes. Yes, yes, no, no. Yes, yes, no, yes. Yes, yes, no, no. Okay, it seems that we all agree that the first two are yes, yes. Is this one yes?
Yep.
Yes. That one's a yes. Why is it a yes?
Because all of the integers have the exponent.
We don't care about the integers. We care
All
about
the
the
variables.
variables.
Sorry.
Okay. all the variables have an equation, an exponent of 1. We're looking for two things here. What are we looking for? We want it to be in two variables, and we want it to be linear. So we want two variables and linear. I see some people changing their answers. Okay? So we agree that this one's a yes. What about that one? We all agreed that that one was a yes. Two variables, exponent of 1. We almost all agreed that 3 was a what? You said yes to 3? To C?
You said like if x is 1, it's still linear.
No, I did not.
That's what you said because
I said y can still be 1, but x has to be 1 in order for it to be linear. But y can be 1 and it still not be linear. Does that make sense? Can't be linear if x is not 1. Okay. Yes or no? No.
No.
Because we got that ugly squared right there. Okay? Now, let's talk about D because D was the source of all disagreements.
I agree.
Yes
Yes.
or no?
No.
Now we've established it's a no. Okay? Why is it a no? There are two variables. Is it linear? Yes. But what kind of linear line is it? Vertical. But we want it to be diagonal, so this would technically be a no. Because it said two variables. Everybody understand the difference? I got a little tricky on you. I try. It's my job in life to be tricky. You can erase. All right. Now, here's why you have new white one workings today. You got white one workings that have graphs on them. Everybody got one? Yeah. Okay, because we are going to start today. Today is your first day of many days of graphing.
Yay.
I know. It's the first day to many days of graphing. There's two ways that we can graph lines. One is by using what they call ordered pair solutions. We call it table of values. Okay? The other is by using the equation and doing slope-intercept form. Today is not that day. Today is our table of value day. Okay? Most of us prefer, probably, slope-intercept form. Okay? But sometimes slope-intercept form doesn't work out well for us. Okay? Maybe sometimes the y-intercept is a fraction and we don't know where to start our graph, so we have to come up with various ways to go around that. Okay? So today we're going to talk about how to make a table of values and how to use that table of values to graph our line. We know that a straight line is determined by just 2 points, right? But our lines are made up of more than 2 points. We're going to graph a linear equation. It's going to require you to find multiple points on the line, and we do that using a table of values. Okay? So let's look at the first one. You ready? All right, go ahead and write this on the side of your white one working. Here's our first equation. 2x plus y equals 5. Now, we need a table of values, okay? This is easier when we all are consistent with our table of values, but you don't have to have the same table of values as your neighbor, okay? My personal favorite table of values, my very favorite, is -1, 0, 1. Those are my very favorite ones to use. Because we all know anything multiplied by 0 is what? 0. We all know that anything multiplied by 1 is itself. And we all know that anything multiplied by -1 is its opposite. Right? It's its opposite. Okay. So that makes our life a lot easier because these what's another name for a table of values? We sometimes call it a, what other kind of table? Input. Input, output, this is my input, this is my output. You got another name for input besides input? Yep.
In like gears, would that be like drive?
I have no idea what you're talking about. I think like maybe like if you're getting like a word problem, is that what you're talking about?
Like in Mr. Gwaltney's class, he said the input's the drive and the output's the driven.
I'm gonna go okay with that, but I have no idea what he's talking about. Okay, I can't say he's wrong, but I have no idea if he's right.
Like my corn planters and stuff, we have like gears. Some of them are the drive and some of them are the driven.
Okay,
The input and output.
sounds like a plan to me. Okay, all right. I was thinking more along the lines of a word that starts with a D.
Decimal.
No.
Denominator.
Domain. And this is the, don't say romaine, that's a lettuce. Romaine is a lettuce. I had it last night for supper. Okay.
Outmain.
Range, domain and range. Okay, so we have an input, output, X, Y, domain, range. They're all the same thing. Okay, you'll hear them say, what is the domain? That really means what's the input or what's the X. Okay, if it asks you for the range. The great way that I can remember them is because they all go alphabetically. X comes before Y, I comes before O, D comes before R. So I can, that's just it's the way my brain works, sorry. Okay? Now, if I have my input, how do I find my output? Yes, sir.
You substitute in.
I substitute in. Everybody agree? Now, I know that you probably know this, but you got to show your work at least a little bit. Everybody ready? And here's how you're going to show your work. If you prefer to solve for Y first, you can. Sometimes that makes it easier if you solve for Y first. Sometimes it doesn't. That's totally up to you. But if I have my domain of -1, I'm going to replace my domain for X. So it's going to go 2 times -1 plus Y equals 5. Everybody okay with that? Yes, no, or maybe?
What? Oh, no. But what is the
What are you supposed to do with the Y? 2 times
Are you
-1
supposed to solve?
plus Y equals 5. What am I supposed to do with the Y?
To solve for one?
I'm supposed to solve for Y.
Yay.
Yay. 2 times -1 is what? -2 plus Y is equal to 5. Now what am I going to do with this -2? Add 2 to both sides. So Y equals what? 7. Okay? So if my input is -1, my output is 7. Everybody okay with that?
Yeah.
If my input is 0, what's my output? 5, because that goes away, right? And Y would be 5. If my input were 1, okay, that would get me 2 plus Y equals 5. Subtract 2 from both sides. Y would be equal to 3. So if my input were 1, my output would be 3. Now, how do I graph that and make it linear? Yes, ma'am.
You make -1 and 7 of 1.
Okay, so I'm going to take my point. You want blue or red? Blue or red?
Blue.
Blue? Okay. Sorry, today's blue day. All right, you weren't fast enough. So on your graph, you would find -1, 7. And you would do, remember, it's X comma Y. So negative 1, 7 is gonna go there. Then what would your next ordered pair be? Yes, ma'am. 0, 5. So 0, 5 is gonna go there. What would my next ordered pair be? Yes, ma'am.
1, 3.
1, 3, and it's gonna go there. Now here's a helpful hint. If you do this, and then you graph them, and they don't make a straight line, you have done something wrong. Okay? Okay. Now, your My Math Lab will only let you graph 2 points. I'm gonna want you to fill in 3 points. Okay, but your My Math Lab, your table of values needs 3 points. Graph will only let you graph 2 of those points. Okay? And I'm okay with that. Everybody okay? But on your work paper, I want you to have 3 points in your table of values.
So we gotta draw a graph.
On your work paper, I want your table of values to have 3 points. Okay? Everybody okay? All right, let's move to the next one. All right, I want you to do this one. What do we want our table of values to be? Negative 1. Oh, we don't want that, hold up. Make sure you label your table of values. Okay, all right, show your work, put in your points, graph it, go. Let me know when you're ready. Because remember, it's only going to have you. Yeah. And if you don't like those ordered pairs, pick another one. Add in another one for you to use. It might help you out a little bit. I love how hard we're working. we ready? Not yet? Okay. I was hoping maybe y'all just forgot to turn your papers over. While the rest of us are finishing up, somebody tell me what you got when your input was -1. What did you get for your output? Yes, sir.
I got 10/3.
10/3. Did anybody get anything different than 10/3? Ooh, I bet we didn't like that, did we? But we got it nonetheless, didn't we? Okay. What did you get when your input was 0? 5. Anybody disagree? Yep.
You have like different X's.
Uh-huh. Okay. What'd you get for your input to be 1? Yes, sir.
20/3.
20/3. Oh, no. Now, why did I add 3 here? So it can help you out, but why does it help you out? Because it makes it a whole number. We like to graph whole numbers. So, what did you get when your input was 3? 10. All right. So, if you had to graph, which of these two should you probably pick to graph? 0, 5, and 3, 10, because they're whole numbers.
Can we do that?
Okay. So, if I'm going to graph 0, 5, I'll make it red this time for the people who wanted red a while ago. 0, 5 would be, hold on, I need that to be darker. Okay, 0, 5 is where? Here?
Yeah.
And 3, 10 is here. Now, when I get ready to draw my line, anybody watch Dancing with the Stars Monday night? Anybody a Dancing with the Stars fan? Because I'm a huge Dancing with the Stars fan. It's my 6-year-old's favorite show, besides American Ninja Warrior. Okay. So, I'm like the grumpy Lynn Goodman. Because he fusses about people who don't have their lines and their arms extended. I fuss about people who don't have their lines extended on their graph. Let me just share with you something. That is not a line. It's not a line. I don't know what world you grew up in learning about a line. That is not one. That's a segment. Okay? Lines look like this. Only straighter. There we go. A little better. Okay? Those are lines. That's what a line looks like. It's nice and extended. It goes on forever in more than one direction. And we can pick another ordered pair if we needed to off of the line. Okay? Everybody okay with that? Yes, no, or maybe?
Yes.
Yes. Okay? Everybody good? Alright. Everybody okay with how to do these?
Wait, is it okay to only graph 2 then?
Yes. Yes. I want 3 to be in your table of values.
Oh, okay.
Your graph will only allow you to graph 2. Alright, everybody okay? Yes, no, maybe.
Yes.
Can you make a table of values and then graph it?
Yes.
Can you decide if it's linear or nonlinear?
Yes.
Okay, everybody okay with that? Alright, then here's what needs to happen. If you can go ahead and clear your white one working.